Clinical epidemiology assumes ergodicity by default. It computes population averages and treats them as descriptions of individual patient outcomes. This assumption is rarely stated. It is almost never verified for individual disease trajectories. The question is not whether population averages are useful. The question is whether they describe what any individual patient will experience. A clinical process is non-ergodic when individual patient time averages do not converge to population averages. The limit either fails to exist or converges to a value different from the population mean. This is not a statistical edge case. It is the structural condition for any disease process with irreversible states, absorbing barriers, or strong path dependence. Most real disease processes have at least one of these properties. 3 structural features produce non-ergodicity in clinical processes. First, multiplicative biological dynamics. Damage compounds rather than adds, causing trajectories to diverge irreversibly. Second, absorbing clinical states. A patient who reaches end-stage disease cannot recover. Third, path dependence. Prior organ damage and cumulative exposure determine future response. Any one of these features is sufficient to break ergodicity. A disease process with fully reversible state changes can be ergodic. Its patient trajectories can return to any prior state. Time averages can converge to population averages. A disease process with absorbing states cannot. Once a patient enters an absorbing state, there is no return. The population average is dominated by survivors. The presence of absorbing barriers destroys the equivalence ergodicity requires. Under ergodicity, the population average describes the typical patient outcome. Under non-ergodicity, it does not. The population average is pulled toward the outcomes of those who survive long enough to contribute. The typical patient trajectory may behave much worse than the mean suggests. Using population averages as the primary quantity under non-ergodicity is a structural clinical error. It describes outcomes that most individual trajectories never reach. Ergodicity in clinical processes can hold under specific conditions: fully reversible disease states, bounded physiological state space, no absorbing barriers, strong mixing across patient trajectories. These conditions describe idealized constructed models, not the absorbing path-dependent dynamics that characterize real disease. Most clinical processes do not satisfy all of them.